as you can see, I want to find the tangent plane to this surface, x squared plus z squared equals 4, at this point, 1, 5, root 3. Okay. Now here, I do not have that z is a function of x and y. In fact, I can see that if I tried to solve for z, I wouldn't get a unique answer because I'd have to take plus or minus the square root. But I do recognize that this equation just involves two variables, so this is a cylindrical surface. And in fact, it's a cylinder because it's just the extrusion of a circle in the xz plane. So basically I've got the circle of radius 2 in the xz plane, and then we're extruding that parallel to the y-axis. So anytime I'm doing that and I want to parametrize, I'm going to basically use one parameter to describe that curve. So I'm going to describe x and z in terms of one of my parameters, and then I'll use the other parameter to do the extrusion. So I'm going to just let y be v, and I'll describe x and z in terms of u. Now, this is just a circle of radius 2. Anytime I have a circle of radius whatever in a plane, one of my variables is the radius times cosine, the other is the radius times sine. So I'm just going to let x be 2 cosine u and z be 2 sine u. So my parametrization is r of uv is equal to 2 cosine u v, 2 sine u. And if I wanted to restrict this so that I just got this once, I could restrict u to only take on values between 0 and 2 pi. All right, excellent. So I've got a point. I want my normal vector. So I'm going to need to take a look at my partials. So the partial of r with respect to u is going to be negative 2 sine u, 0, 2 cosine u. Now, I need to evaluate that, but I'm not evaluating that here because that's not a u and v value. That's an x, a y, and a z. So I'm going to have to figure out what values of u and, well, I guess there's no place to plug in v, but I need to figure out what values of u and v put me at this point. So I think v is probably the easiest. V is going to have to equal 5 because y is v and y is 5. Okay, now if I look at my x value, that's supposed to be 2 cosine u, and at this point that's just 1. That means that cosine of u has to be 1/2. My z value is 2 sine of u, and that's root 3. So that means that sine of u has to be root 3 over 2. So u has to be an angle where sine and cosine are both positive, so that puts it in quadrant 1. And I recognize an acute angle that has those properties. U can just be pi over 3. So I'm going to evaluate this at pi over 3, 5. There's no place to plug in the 5, but that's the point that I am plugging in. So sine of pi over 3, that we said was root 3 over 2. So negative 2 copies of that is going to be negative root 3, 0. Cosine of root 3 over 2, sorry, cosine of pi over 3, my bad. Cosine of pi over 3 was 1/2. 2 of those is going to be 1. Okay. All right. I can take the partial of r with respect to v. That's actually really nice. That's just 0, 1, 0. And of course, since that's constant, I'll get that no matter what I plug in. So that's what I get when I plug in pi over 3, 5 as well. Okay. All right. So now I'm able to say that my normal vector is just going to be the cross product of these two vectors. So n is del r del u at pi over 3, 5, crossed with del r del v at pi over 3, 5. That's the symbolic determinant I, j, k, negative root 3, 0, 1, 0, 1, 0. So for the i's, I'm getting nothing minus 1. For the j's, I'm getting nothing minus nothing. And for the k's, I'm getting a negative root 3. So, this is my normal vector. I'm going to dot that with a vector that I get by looking at, if I had just Q being an arbitrary point x, y, z, and this is my point P, I'm basically going to dot this with PQ to get 0. So n dotted with PQ, which will be parallel to the plane, is 0. So that's negative 1, 0, negative root 3, dotted with x minus 1, y minus 5, z minus root 3 is equal to 0. And I do ask that you don't leave the equation for your plane with vectors in it, that you actually work out what that dot product is. So that's negative quantity x minus 1, 0, the y's drop out, minus root 3, quantity z minus root 3, and all of that is equal to 0. If I want to simplify more, I certainly can, although I'd be fine with you stopping here. This is negative x plus 1 minus root 3z, and then just plus 3 equals 0. So I think what I might do is just add the 1 and the 3 together to get 4 is equal to, I'm going to add the others over, x plus root 3 times z. But once you've eliminated the vectors, you've simplified far enough that you can stop. I could just sort of see that the 2 root 3's were going to work out pretty nicely, so I went ahead and took it a little bit further.